Hello everyone, I'm Paul and today we're solving problem 2966, divide array into arrays with max difference. This is medium and this is all about observations, so here I will show you my thought process and how to solve this step by step. We're given an integer array nums and an integer k, and we need to split this array into small arrays of 3 elements. This nums array has a size which is a multiple of 3, so we can do this. And in each of these smaller arrays of size 3, the difference between any two elements is less than or equal to k. And finally, we need to return a 2D array containing the small arrays. And if it is impossible to satisfy the conditions, we need to return an empty array. And this is also important. If there are multiple answers, we can return any of them. So let's say we have this is nums and this is k. And now the question is, how can we distribute the differences in this array in the best possible way? Because, for example, here we have a 9 next to a 3, but this doesn't seem to be very optimal. So here we can sort this as the first step. So now we have this, and now we can see everything more clearly. We can iterate this in steps of 3. So we will start with the I pointer here at index 2, and every time we are moving the I pointer 3 steps. So now we have this subarray. And we need to check the difference between 1 and 1, which is 0, the difference between 1 and 3, which is 2, and the difference between 1 and 3, which is also 2. And none of these differences is greater than k, so we are good to go here. So we add to the result a small array with 1, 1, 3. Now the I pointer is here and we are checking the differences in this subarray. So first, the difference between 3 and 4 is 1, the difference between 4 and 5 is 1, the difference between 5 and 3 is 2. So none of these differences is greater than k. This means we are good to go. So we add to result an array with 3, 4, 5. Finally, the I pointer is here, so we are checking this subarray, and the difference between 7 and 8 is 1, the difference between 8 and 9 is 1, and the difference between 9 and 7 is 2. None of these differences is greater than k, so we are also good to go, so we add this to the result. Finally, we update I, we reach the end, and we return this. Time complexity for this approach will be big O of n log n, because we need to sort this, and space complexity will be big O of n, because sorting requires that complexity, and we also need to build this array which we need to return. So this is it for the approach. Now let's go with the code and hopefully you will get the idea. First, we need to sort this array, so nums.sort n equals the length of nums, and the result is initially an empty array. We'll finally return this result, and here in between we will say for I in range from index 2 up to n in steps of 3. Here we'll have 3 differences. We'll call the first one df1, and this is the difference between the second element and the first element, meaning nums at I minus 1 minus nums at I minus 2. df2 will be the difference between the third element and the second element, meaning nums at I minus nums at I minus 1, and the first difference, meaning df3, is nums at I minus nums at I minus 2. And now if df1 is greater than k, or df2 is greater than k, or df3 is greater than k, we return an empty array, which is what the problem requires. Else, we can add to the result an array of size 3 with the elements num_sat i-2, num_sat i-1, and num_sat I. So this works. You can try and submit this and this will work, but here we can optimize this. If the difference between the third element and the first element is greater than k, this means that somewhere in between we have a difference that's greater than k. So we can remove this and just keep this difference df3, and here we can remove this, and this will also work. So I will submit this just to show you this works. Let's try. And as you can see, this also works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.